Hello friends, welcome back to my channel. So in this tutorial we are evaluating the integral from 0 to infinity with the natural logarithm of 1 plus x squared divided by 1 plus x squared dx. So how do we evaluate this integral? Before we proceed on the tutorial, make sure you are supporting my channel by smashing the subscribe button so I will continue uploading, engaging and challenging tutorial on integrals. So let's dive right into this. So we can first start off by doing a very simple trick step. You can let x to be equal to tan of theta. So dx d theta is equals to secant square theta. That implies dx is equals to secant square theta d theta. It means wherever you see dx in our integral, we plug in secant square theta d theta. Let's do the change in limits. When x is equal to 0, what happens to theta? So we have tan theta is equals to 0. That implies theta is equals to the arctan of 0, which is equals to 0. When x is equals to infinity, we have tan theta is equals to infinity. That means theta is going to be the arctan of infinity, which is pi over 2. So tan of pi over 2 is equals to infinity. Arctan of infinity is pi over 2. So we can now plug everything from change everything from the x world into the theta world. So our integral now becomes the integral from 0 to pi over 2 natural logarithm of 1 plus x. X is tan theta divided by 1 plus tan theta squared times dx. Dx is secant square theta d theta from here. That evaluates nicely to the integral from 0 to pi over 2 of the natural logarithm of 1 plus tan square theta over 1 plus tan square theta times secant square theta d theta. What does this one give? This one simplifies to the integral from 0 to pi over 2 of the natural logarithm of secant square theta all over secant square theta times secant square theta d theta. The secant square thetas will cancel. I left with the integral from 0 to pi over 2 of the natural logarithm of secant square theta d theta. That is just from the trig identity. Secant square theta is equals to tangent square theta plus 1 from here. So you can just plug in secant square theta in place of tangent square theta plus 1. So our integral has been reduced to this. Our integral is now the integral from 0 to pi over 2 of the natural logarithm of secant square theta d theta. And using the laws of logarithm, the 2 can come in front. So we have integral from 0 to pi over 2 to natural logarithm of secant theta d theta. So which can come in front of the natural logarithm of secant theta d theta. So the task now is to evaluate this integral. Secant theta d theta. But this one, we can do a simple manipulation by multiplying the number in front by -1. When we do that, we will nullify the negative in front by multiplying a -1 again inside, like that. Secant theta d theta. Using the laws of logarithm, the negative here can become a power in a logarithm. So that's going to be the secant theta to the -1. So it's just going to be like this, the theta. And 1 over secant theta, because secant to the -1 is 1 over secant theta. And 1 over secant theta is going to be cosine theta. So that is the same as -2 integral from 0 to pi over 2 of the natural logarithm of cosine theta d theta. So this is our integral. So here in my last tutorial, we use some sort of a property to evaluate this kind of integral, but this was natural logarithm of the sine of theta. But we can use the same property here, and we are going to solve this integral nicely. The property we used in the last video, in the last tutorial, was the King's property. Using the King's property, which states that the integral from a to b of f of x dx can be written as the integral from a to b of f of a plus b minus x dx. So we can do that here. So we can evaluate the integral from so we leave the negative 2 for now and evaluate the integral from 0 to pi over 2 of the natural logarithm of cosine of x dx. So let's do that. So the integral from 0 to pi over 2 of the natural logarithm of cosine of x dx. There are thetas. Sorry about that. Theta. D theta. This, using the King's property, is going to be the integral from 0 to pi over 2 of the natural logarithm of cosine of pi over 2. So cosine of 0 plus pi over 2 is pi over 2 minus x. Our x here is theta. D theta. So we can call this one I. So our I now becomes the integral from 0 to pi over 2 of this one, cosine of pi over 2 minus theta. You can use the double angle identity, which is cosine of pi over 2 cosine of theta plus sine of pi over 2 sine of theta, like that. So this one reduced to cosine of pi over 2 is 0, 0 times cosine theta is 0, sine pi over 2 is 1, 1 times sine theta is sine theta. So this is the same as cosine of pi over 2 minus theta. So in place of cosine of pi over 2 minus theta, we can just replace with cosine of sine of theta. So that is going to be the natural logarithm of the sine of theta, d theta. So I can erase this. Initially, I was equal to this. The same I is equal to this. So we can just sum them. We can say I plus I in the left hand side is equal to the integral. The first I was from 0 to pi over 2 of the natural logarithm of cosine of theta d theta plus the next I, which is this one, 0 to pi over 2 of the natural logarithm of sine of theta d theta. Now left hand side is 2i, which is equal to the integral from 0 to pi over 2 of this is the same as natural logarithm of cosine of theta plus the natural logarithm of sine of theta, all d theta. So 2i is going to be the integral from 0 to pi over 2 of the natural logarithm using the laws of logarithm. That is going to be cosine theta sine theta d theta. That is by multiplying the terms. You can refresh your memory again. So if you have sine 2 theta is the same as cosine theta sine theta. There's 2 here. So this one looks like sine 2 theta, but we have to divide by 2. When we divide by 2, then this 2 cancels this 2. Then we are left with cos theta sine theta is equal to sine 2 theta over 2. So this one can be replaced with sine 2 theta over 2. So 2I is the same as the integral from 0 to pi over 2 of the natural logarithm of sine 2 theta over 2 d theta. So using the laws of logarithm again, we have integral from 0 to pi over 2, the natural logarithm of sine 2 theta d theta minus the integral from 0 to pi over 2 of the natural logarithm of 2 d theta. So natural logarithm of a over b is natural logarithm of a minus natural logarithm of b. So 2I is going to be the integral from 0 to pi over 2 of the natural logarithm of sine of 2 theta d theta minus, this is a constant, so integrating in the theta world is just going to be natural logarithm of 2 theta integral from 0 to pi over 2, like that. So 2I here is going to be the integral from 0 to pi over 2 natural logarithm of sine of 2 theta d theta minus plugging in our limit, that is going to be pi over 2 natural logarithm of 2 minus plugging in 0 is 0, so that is, so 2I is going to be the integral from 0 to pi over 2 natural logarithm of sine of 2 theta d theta minus pi over 2 natural logarithm of 2. Now our task now is to do a simple u sub here. Can let u to be equal to 2 theta. So du is going to be 2 theta d theta. So in that case, the theta is going to be half du. What about the limits? When theta is equal to 0, u is going to be 2 times 0, which is 0. When theta is equal to pi over 2, u is going to be 2 times pi over 2, which is equal to pi. So we can take everything from the theta world into the u world. So that implies we have 2I to be equal to the integral from 0 to pi of the natural logarithm of sine of u. And d theta is going to be half du minus our pi over 2 natural logarithm of 2. So 2I is going to be 1/2 is a constant, comes in front, the integral from 0 to pi over, from 0 to pi, natural logarithm of sine of u du minus pi over 2 natural logarithm of 2. This one can be split into two integrals, which is integral from 0 to pi of the 0 to pi over 2 of the natural logarithm of sine of u du plus the integral from pi over 2 to pi of the natural logarithm of sine of u du minus pi over 2 natural logarithm of 2. All this multiplied by 1/2. But this can be split into two integrals. From 0 to pi over 2 and from pi over 2 to pi is 2 times the integral from 0 to pi over 2. So this is 1/2. This is 2 times the integral from 0 to pi over 2 of the natural logarithm of sine of u du minus pi over 2 natural logarithm of 2. Now, this 2 and this half will cancel out. They allow the integral from 0 to pi over 2, the natural logarithm of sine of u du minus pi over 2 natural logarithm of 2. But what is this? We can scroll back up. That is the same as I. That is from here. I is the integral from 0 to pi over 2 of the natural logarithm of sine theta d theta. It's just the theta that is now u is the same variable. So that is the same as I. So this is I. So we have 2I to be equal to I minus pi over 2 natural logarithm of 2. So we can do the subtraction, subtract I from both sides. We have I to be equal to negative pi over 2 natural logarithm of 2. So we have gotten our I. Originally, what was the I? This was the I. The I was integral from 0 to pi over 2 of the natural logarithm of cosine of this. So that is I. So I is the integral from 0 to pi over 2 of the natural logarithm of cosine of theta, d theta. And that is equal to negative pi over 2 times the natural logarithm of 2. But this is not the integral we wanted to solve. We wanted to solve for this integral. The integral we wanted to solve reduced to negative 2 times what we got. So we just have to multiply our answer by negative 2. So this we got, and we just have to multiply by negative 2, and that should be the answer to our integral, our original integral here. So just to multiply our answer down there by negative 2. So our integral, which is the integral from 0 to infinity of the natural logarithm of 1 plus x squared all over 1 plus x squared dx, was negative 2 times the integral I, which is equal to negative 2 times negative pi over 2 times natural logarithm of 2. This is the same as pi times natural logarithm of 2. So therefore, our integral from 0 to infinity, the natural logarithm of 1 plus x squared over 1 plus x squared dx, is pi natural logarithm of 2. So this is the answer to our definite integral. Yeah, so if you find this helpful, make sure to smash the subscribe button, like the video, hit the notification bell for more content. Thank you so much for watching, and I will see you in the next one. Bye bye.